So asymptotes is something that you've probably covered already in school, but we should cover it again. So there's vertical and horizontal asymptotes. Okay, so what's a vertical asymptote? Okay, so a vertical asymptote is a vertical line in your graph where the graph tends towards plus or minus infinity. So we say that the line x equals c is a vertical asymptote of your graph if, as you approach c from the left or from the right, the graph tends towards plus or minus infinity. So that's basically four possibilities, and maybe I'll put them all down. If one of the following holds, okay, so as you approach the c from the left, your function could tend towards plus infinity. That's one possibility. Or as you approach c from the left, the function could tend towards minus infinity. Okay. Or as you approach c from the right, the function could tend towards infinity. Or as you approach c from the right, the function could tend towards minus infinity. Okay, so each of these has an associated picture. So in this case, as you're approaching c from the left, the function is tending towards infinity. So the picture looks like this. Here's the graph approaching this vertical line x equals c, and the graph's tending towards plus infinity as you're approaching c from the left. Here, as you're approaching c from the left, the graph's tending towards minus infinity. Here, as you're approaching c from the right, the graph's tending towards plus infinity. And here, as you're approaching c from the right, the graph's tending towards minus infinity. And you could have combinations of these. So this is what happens as you're approaching from the right, and this is what happens as you're approaching from the left. So we could say more precisely, we could say that, for example, the line x equals c is a horizontal asymptote of type, vertical asymptote of type, and then I draw a picture. So this is not something that's in the book, but I think this is sort of my way of doing it, and I think it adds value when it comes to the time to do the curve sketching. And in the examples that I uploaded last week, Thursday, of curve sketching, I did all the asymptotes this way, and I think you'll agree with me that it actually helps when it comes to the time of drawing the graph. So what you do is you just look, okay, what happens as I approach c from the left, and you see, well, maybe the graph either goes to plus infinity or minus infinity, and then you draw that in. So maybe in this case it went to plus infinity as you approach the line x equals c from the left. And as you approach it from the right, maybe it went towards minus infinity, then you would draw it over here. Maybe it went to plus infinity, then you would draw it over there. Or maybe it didn't go to plus infinity or minus infinity at all as you approach from the right, then you wouldn't draw anything on the right. That sometimes happens, but it's very rare. Okay, horizontal asymptotes. So the previous was vertical asymptotes, now we're doing horizontal asymptotes. Okay, so the horizontal line, sometimes it's nice to actually write out horizontal line just to remind ourselves that the horizontal line is given by y equals a constant, right? Don't get confused about that. The horizontal line y equals b is a horizontal asymptote. I'll just write HA for horizontal asymptote of the graph of f of x. If so as x approaches infinity, the function approaches b, or as x approaches minus infinity, the function approaches b. Okay, that's the only two possibilities, and it could be different, by the way. We won't give you such a hard graph generally, but we might happen that as x approaches plus infinity, the graph approaches b, and as x approaches minus infinity, the graph approaches some other number, c. Okay, that can happen. Anyway, graphically we might be a bit more precise. So we can graphically write, for example, this is sort of my notation, but it's helpful for drawing curves. So you could write that the line y equals b is a horizontal asymptote of type, and you draw a picture of a horizontal line, and then you indicate on the picture how the graph is approaching this horizontal line as x goes to plus or minus infinity. So maybe as x goes to minus infinity, the graph's approaching the horizontal line from above. And as x approaches plus infinity, maybe it's also approaching the horizontal line from above. That can happen. Okay, and I will see how this works out in examples now. Examples. So simply find the vertical and horizontal asymptotes of the following functions. By the way, we're not going to do 8.6 in this course, which is oblique asymptotes. So our asymptotes will always be vertical or horizontal. So the first function is y equals 2x over x minus 3. So let's find the vertical asymptotes. Let's see. So to find the vertical asymptotes, what you do is you look at the formula for the function, and if it's a rational function, in other words, some polynomial over some polynomial, like this one is, then generally speaking, you're going to get a vertical asymptote whenever the denominator tends towards 0, because then you're going to get something over 0, which is going to tend towards plus minus infinity. I say generally speaking because you might have a factor in the top which cancels that factor in the bottom, so be careful about that. Always do some algebra in the beginning to make sure that there's no cancelling factors occurring. Okay, once you've done the algebra, now you can start working. So in this case, we notice that as x approaches 3, this thing's going to blow up. So the way we write that down is we say as x approaches 3, I must be more precise, as x approaches 3 from the left, what happens to the function? Well, let's see. 2x over x minus 3 is the formula. So as x approaches 3 from the left, 2x just approaches 6. There's no problem with that. Okay, it approaches 6 from the left, but that's irrelevant. What's more important is that x minus 3, well, x is approaching 3 from the left. In other words, 2.8, 2.9, 2.95, 2.98. So when you subtract 3 from that, you'll be getting out small negative numbers. So this is approaching 0 from the left. So therefore, we've got a positive number over a number approaching 0 from the left would then tend towards minus infinity. Okay. as x approaches 3 from the right, 2x over x minus 3, what happens now? So again, the top is approaching 6. What's happening at the bottom? Well, x is approaching 3 from the right, for example, 3.2, 3.1, 3.01, 3.001. So when you subtract off 3 from that, you're approaching 0 from the right. So therefore, we've got a sequence of numbers, 6 over 0.1, 6 over 0.01, and so on. That's tending towards plus infinity. So the way we write that down is we say, therefore, x is equal to 3 is a horizontal asymptote of type. Draw a little line here. You don't have to do this, but I think it's very helpful. So as x, yes. I always get this confused. Don't make the same mistakes I do. Horizontal asymptotes, and we're actually doing vertical asymptotes here. So I draw a vertical line, and as x approaches 3 from the left, the graph's tending towards minus infinity. As x approaches 3 from the right, the graph's tending towards plus infinity. So it looks like that. Okay, that's just the way we write it down. Right, so let's do the horizontal asymptotes. Okay, so we stare at our formula and we consider what happens as x tends towards plus infinity, say. So our formula is 2x over x minus 3. And since we're trying to figure out the limit as x goes to plus or minus infinity, we can take out the highest power of x from top and bottom here. So we can write this as 2 over 1 minus 3 over x. Okay, and then we observe that this thing on the bottom, so x is tending towards plus infinity, which means that 3 over x is tending towards 0 from the right. So 1 minus 3 over x is tending towards 1 from the left. Excuse me. So we've got, so for example, it'll be 0.9, 0.995, 0.998, and so on. So 2 divided by that would be, these are numbers that are slightly smaller than 1. So 2 divided by numbers that are slightly smaller than 1 gives you numbers that are slightly bigger than 2. So this tends towards 2 and tends towards 2 from the right. Okay, because you're getting numbers that are slightly bigger than 2 as the bottom tends towards, as x tends towards infinity. And similarly, as x tends towards minus infinity, what happens? So we've got this same expression here, 2 over 1 minus 3 over x. So the bottom, what happens here? So x is tending towards minus infinity. That means that 3 over x tends towards plus 0. In other words, tending towards 0 from the right. Or minus 3 over x. In other words, this let me say it more succinctly. As x tends towards minus infinity, 3 over x tends towards 0 from the left. So 1 minus 3 over x tends towards 1 from the right. So 2, in other words, 1.1, 1.01, 1.001. So 2 over a number that's slightly bigger than 1 is going to be a number that's slightly less than 2. So this is going to tend towards 2 from the left. Okay, so therefore we conclude that y equals 2 is a horizontal asymptote of type. We draw a little dotted line. And then as x goes to plus infinity, we're approaching 2 from above. As x goes to minus infinity, we're approaching 2 from below. Okay. Right, next example. Y equals 2 plus 1 over x minus 5 squared. So we first of all calculate the vertical asymptotes. We look at the formula for the function and we think, when is this formula going to blow up? Well, it's basically a rational function, so as x approaches 5, the formula is going to blow up, and we should just investigate a little bit more precisely how it's going to blow up. So as x approaches 5 from the left, what happens to the formula for the function? Well, let's see. X is approaching 5 from the left, so for example 4.9, 4.95 and so on. So this number is approaching 0 from the left. The thing that then after we square it, it's approaching 0 from the right, because minus 0.1 squared is 0.01 and so on. So this denominator is approaching 0 from the right. So 1 over a number that's approaching 0 from the right will approach plus infinity. Okay, as x tends to 5 from the right, what happens to the formula for the function? Okay, again, x minus 5 is now approaching 0 from above. X minus 5 squared is still approaching 0 from above. So 1 over x minus 5 squared will approach infinity. Okay, so therefore the line x is equal to 5 is a vertical asymptote of type so as x approaches 5 from the left, the graph approaches plus infinity. As x approaches 5 from the right, the graph also approaches plus infinity. Okay. Right, horizontal asymptotes. So now we ask the question, what happens as to the formula for the function as x approaches plus or minus infinity? So as x approaches plus infinity, what happens to the function? Let's see. X is approaching infinity, so x minus 5 is also approaching infinity. So x minus 5 squared is also approaching infinity. So this thing in the bottom is approaching plus infinity. So 1 over a number that's approaching plus infinity will tend towards 0 from the right. And then I add that to 2, and then I would get something that approaches 2 from the right. Okay, as x approaches minus infinity, what happens to the formula for the function? Again, this thing on the bottom is approaching plus infinity. The reason is because x is approaching minus infinity, so x minus 5 is approaching minus infinity, but then once I square it, I get something that's approaching plus infinity. So 1 over a number that's approaching plus infinity will tend towards 0 from the right. So 2 plus a number that's tending towards 0 from the right will tend towards 2 from the right as well. So therefore we write y equals 2 is a horizontal asymptote of type, we draw a little line. And so as x approaches plus infinity, the function approaches 2 from above. As x approaches minus infinity, the function approaches 2 also from above.